Just to make sure everybody understands that tomorrow we are doing a lab that involves the burners. So that's important for you to make good decisions about what to wear and about wearing your hair back, bringing hair ties so that you can wear your hair back. Your homework tonight is to complete the back side of the white worksheet, which is what we're going to be taking notes on today. On the front side, you're going to be completing the back side. It should not take any more than 10 minutes. I want to take a few minutes to explain the flipped lesson, though, what that flipped lesson is all about. By Monday, you guys are going to watch a movie that I will have posted to my website. This movie is about 20 minutes long, and it's a lesson of me teaching you how to do metric conversions. It's kind of a cool thing. You guys will be able to sit in the comfort of your home, watch the movie, take notes as you're watching it, follow along, and if you want to, you can stop it, pause it, finish writing what you need to write. You can rewind and watch a part over again if you're not sure about how to do it. And you can work out the sample problems right along with me on this video. It's kind of a really cool thing. Then the idea is you come back to school on Monday, and I will help you with me. You will practice that new information. Right now, a lot of the time what happens is I do notes with you in class, and then I send you off at home to do some homework. How many of you have gotten home before and you look at the homework and you say, oh, shoot, I don't remember how to do this? How many has that ever happened to anybody in this room? Where you get home, you get to your house, and you can't remember how to do a math problem, or you couldn't remember how you were supposed to outline the chapter in social studies or whatever, okay? The idea about this flipped lesson is you do the easier part, the learning, the lesson, the taking notes, at home by yourself. You do the harder part with me. So when you practice that new information, I'm here to help you when you get stuck. Kind of a cool concept. Any of you have any older brothers and sisters at the high school? Have you heard of them doing flipped lessons before? There's quite a few teachers. Yeah, I see a few heads nodding. There's quite a few teachers up at the high school that do the flipped lessons. And so it's kind of a cool thing to do. We're going to do it every now and then, not a lot, but every now and then we'll sprinkle those flipped lessons in because they are very, very appropriate. On the left-hand side, when you come to my School Point webpage, you will find those video lessons are going to be over in this part. I will have it posted hopefully by 3 o'clock today so that you can watch it anytime you want. Starting today, after school, tonight, you can do it tomorrow during lunch. If you want to come in 5th period during your lunch recess and watch it with Mrs. Krogan, you can. Tomorrow after school, you've got Saturday, Sunday. You can do it Monday during lunch, Monday before school, just so that it's done before you walk into this classroom Monday, 8th period, okay? Now, I realize not everybody has internet access at home. I just want to point out, if you need to, you can you're going to have to plan time to watch it here at school. You could also go to the public library. The public library has internet access, and you can borrow a computer there if you need to. If you know this is going to be a problem because you don't have internet access at home, you need to talk to me about it today or tomorrow. You need to say, Mrs. Frankman, I'm not going to be able to get this assignment done. And that is so cool. That is okay. I will help you get the assignment. I will help you get the lesson without you needing the internet, okay? Don't walk in here Monday, 8th period, and say, oh, sorry, Mrs. Frankman, I didn't watch it. I didn't have the internet at home. That's not going to work. You can't pull that card Monday, 8th period. You have to talk to me about it before then. Is that clear? Now, there's two pieces of paper that go along with the flipped lesson. The gold piece of paper and the purple piece of paper. Gold and purple, okay? The gold piece of paper looks like a whole lot of nothing. It's a chart, and you will see how that chart fits into the lesson very quickly. In fact, you might even be able to figure out how it fits into the lesson at the end of our lesson today. The purple piece of paper has the practice problems that will go right along with that lesson. So I don't know if you want to write on the purple and the gold. You can write flipped and then video, and then that'll remind you that these two pieces of paper go with that flipped video lesson, okay? The purple and the gold go with the flipped video lesson. Does that make sense? All right, so like I said, I'm kind of excited about it, and once again, I'm really expecting you on Monday to come in here prepared for the next step, okay? So now we're going to talk about the metric system, what it's all about, why we study the metric system. And I've got a nice, cute little video here that's going to help explain that.
Our U.S. standard system of measurement developed. How is the metric system divided? How are the two systems different? Let's begin our measurement journey by visiting the Peninsula Fine Arts Center in Newport News, Virginia.
People have been measuring things for thousands of years. Hey, that's one thing we measure, time. What are some of the other things we measure? Temperature.
Outer space is in your garage. That's the way. I have to use it. What? How long is your tree?
Get this. The ancient Egyptians used their fingers, hands, and even arms to measure things. There were no measuring tools like rulers back then. The width of one finger was a digit, and the width of 4 fingers was a palm.
Here's another ancient Egyptian measurement. Open your hand and spread out your fingers just like this. The distance from the tip of your thumb to the end of your little pinky was called a span.
The ancient Egyptians also created a measurement called the cubit. If you bend your arm, the distance from the elbow to the tip of your middle finger is a cubit. In the ancient world, the cubit was the most popular way to measure length.
So you see, all these units of measurement were based on something familiar to ancient people. Body parts.
Of course, using your hand or elbow to measure a pyramid would take forever.
Not only that, it's not an accurate or exact measurement. Here's why.
My friend Jimmy is taller than I am. It takes 4 of my cubic arm lengths, but only 3 of his to measure my butt. How can we get the same measurement if our arms are different lengths?
Good point. In ancient Egypt, it was up to the pharaoh to decide how to make measurements standard or the same for all situations.
So the standard cubit length was set by the length of the pharaoh's arm. But even then, it could be pretty tough measuring a pyramid with a pharaoh under your arm.
As time went on, people created many ways to measure things. Unfortunately, none of them were the same when it came to mathematics. You see, scientists couldn't repeat each other's experiments because there was not an agreed-upon standard of measurement. Today, our world operates according to 2 different systems of measurement. Here's some expert help.
In the U.S. standard system, the inch, foot, yard, and mile developed from traditional practices of measurement dating back to ancient times. One disadvantage of the U.S. standard system is the different size units often have no simple relationship to each other. For instance, there are 12 inches in a foot, 3 feet in a yard, 1,760 yards, or 5,280 feet in a mile.
Converting different units of measurement, like miles to inches, requires some math. Here's an example. It's about 431 miles from Los Angeles to San Francisco. To convert these miles into inches, simply multiply the number of miles, 431, the number of feet in a mile, 5,280, by the number of inches in a foot, 12. miles converts to 27,308,169 inches.
Using the decimal system is a much easier way to measure and change units. Because earlier systems of measuring units were so confusing, the decimal system was devised. This system is based on tens and multiples of tens. Tenth numbers, or decimals, are easier to use than the U.S. standard system, which is based on twelfths. One advantage of the decimal system is the decimal point. Depending upon where it is moved, whole numbers can become fractions or multiples of tens.
Thanks, Dr. Morgan. We now know why there is a metric system of measurement.
Yep, and the metric system is based on the meter. The original meter was not the length of someone's finger or arm. Instead, it represented 1/10,000,000th of the distance from the North Pole to the equator. Hey, the meter is the most widely used measurement system for scientific work. Using the metric system, we can easily convert units with some mental math. For example, we know Los Angeles is approximately 600 kilometers from San Francisco. Now, if we want to know that same distance in meters, for example, all we have to do is multiply by 1,000. Why? Because there's 1,000 meters in 1 kilometer. So you multiply 600 times 1,000 and you get 600,000 meters. 600 kilometers is the same as 600,000 meters.
The Egyptians would have appreciated the meter stick. It's better than a pharaoh's arm.
Better than a pharaoh's arm. Okay, so we have an idea about what is good about the metric system. We have a little bit of an idea what's good about the metric system. What did you find out from the movie? What's the bonus feature of the metric system? Elise?
More precise.
It's very precise. What else? Yeah? Yeah, it's used by most of the world. What was the best feature of it? Yes. It never changes, right? Yeah, it's all done in the powers of 10, which makes it so easy. You know, if you think about the English system of measurement, there's 12 inches in a foot. There are 3 feet in a yard. How many feet are in a mile? 5,280, something like that. Ridiculous numbers that you have to remember. Really ridiculous. Whereas in the metric system, you are simply moving decimal points one direction or the other if you are converting between different metric prefixes. So it makes it very, very easy. It is used by most of the world. I love the map. I absolutely love the map of the world. Everything that is gray uses the metric system. Everything that is red uses the English system of measurement. You can see, of course, the United States there, bright red, Alaska and Hawaii. But here's the ironic thing. Look at this. Look at this. What does England use? What does England use? What color is it? Gray. England, are you guys okay? I'm asking questions and you're like all staring up at me like I'm, you all right? You with me? Yes, the gray, the English system is not used in England. They use the metric system in England. It's crazy. So it's really unfortunate. There was a big push back in the 70s for the United States to switch to the metric system, but there was just a lot of resistance. People didn't want to learn new values, okay? But I can assure you, if you're a scientist in the United States, that you are also using the metric system. And as students in this classroom, you are certainly going to use the metric system as well. Quite often you'll see SI related to the metric system. That is the French way of saying System International, or the International System of Units. That is the official name for the metric system. Metric is kind of slang. It's kind of like a lazy man's way of saying the International System of Units. But it is a standardized system of units, so that 1 meter in the United States equals 1 meter in Australia. It equals 1 meter in Brazil, 1 meter in South Africa. So it's a universal, standardized way to measure things. And I love my little silly cartoon, I got you 10 roses. I believe strong relationships are based on the metric system. Instead of a dozen roses, you only got 10 roses. Get it? There we go. All right, we talked about this yesterday, and we're going to just add this to your notes. Okay, we're going to first talk about the base units. The base units let me know what is being measured. They let me know what is being measured. For instance, am I measuring mass? Am I measuring volume? Am I measuring length? So the base units give me the clue. The base units tell me what I'm actually measuring. We're starting off with the base unit of length, which is the word meter. Length, to remind you, is the distance between 2 points. The base unit is the meter, and it's abbreviated with a small m. So if I see 7m, I know that stands for 7 meters, and I know that's measuring a length or a distance. Just to give you some ideas of size, 1 meter is equal to the distance from a doorknob to the floor. The distance from a doorknob to the floor, 1 meter. And I think I told you yesterday, my pinky is around 1 centimeter wide, just to give you an idea of size. The next metric the next metric base unit, is the gram. When I see the gram, I know that we're measuring mass. Mass is the amount of matter in an object. And when we're talking about the word matter, I'm talking about, I call it stuff. It's the stuff of the universe. It is literally the number of atoms and molecules in an object. I have a picture here of a paper clip and an M&M and a potato chip, because all of these things have a mass of around 1 gram. They all have the mass of about 1 gram. And then lastly, the last metric base unit that we're going to talk about today is the liter, and that stands for liquid volume in particular. Volume is the amount of space an object occupies. When we're talking about volume, we're talking about the size of the object. How big, how small. So when I see like 7 liters, I know that, or 7 with a capital L, I know that is a measurement of volume. I know you guys know size relationships when you're talking about volume because you know what a 2-liter pop bottle looks like without any problems there. I also want to point out it's always a capital L as opposed to a lowercase l. Does anybody want to tell me why? Why would that be, Brandon? Yeah, the lowercase l looks like a 71, so you always want to use the uppercase L when you're talking about liters, the volume of something. Okay? So we know the base units now. It is the meter for length, liter for volume, and gram for mass. These are the words, the base units. They are the words that let me know what is being measured. The words that let me know what is being measured. Meter, liter, gram. Okay, so now that we have an idea about those base units, now we're going to start talking about metric prefixes. Before we go too far, can somebody tell me what is a prefix? What is a prefix? Yeah. Yeah, very good. It comes before the word. And it modifies or changes the meaning. Okay? A good example would be a bicycle or a unicycle. Okay? The prefix una and bi. Una means one, so one wheel, or a bicycle, bi means two, bicycle, 2 wheels. Okay? So we are going to talk now about these metric prefixes. What they do is they modify, they come before the base units, and then they modify them. So we put a metric prefix plus the base unit, and what we get is a large range of sizes with which to measure. I'm sure you guys remember the word range from max, min, medium, mode, all of that. Range is the largest to the smallest. So when we put these metric prefixes, together with those base units, it gives us a really nice large range with which to measure objects. Things that are as small as the end of your pencil, we can measure those sizes, all the way up to distances like the circumference of the Earth. So it gives us a large range. Okay? We're going to start here at the base, because this is kind of like the middle. The base is where I have 1 whole meter, which is like the meter stick that you have on your desk. You have 1 whole gram, which would be like the mass of a paper clip. And you have 1 whole liter. Now, the metric prefixes that are above my base units, all of these metric prefixes here, kilo, hecto, and deca, these metric prefixes all mean more than 1 whole thing. And I'm talking meter, liter, gram. So when I'm using the metric prefix kilo, I'm talking about more than 1 meter stick. When I'm talking about hecto, I'm talking about more than 1 meter stick. When I'm talking about deca, I'm talking about more than 1 meter stick. The bottom below my base, deci, centa, and milla, all of these prefixes are less than 1 whole meter, liter, or gram. In other words, I am literally chopping up the meter, the liter, or the gram into smaller pieces. Now, I have kangaroos all over this paper, and it's a little goofy, but I promise you it works. It's a mnemonic device that I use to help me remember the metric prefixes in order from the biggest ones to the smallest ones. And my mnemonic device is that kangaroos have dandruff, but don't care much. Kangaroos have dandruff, but don't care much. Everybody should be writing that down. Kangaroos have dandruff, but don't care much. Kangaroos have dandruff, but don't care much. I promise this is one of those things when you're up at the high school, you're going to like, oh my gosh, Mrs. Brankman, I remember. These things stick in your head. It's silly. Who's heard of a kangaroo with dandruff? I bet they have dandruff, but who's heard of that? That's weird. That means you'll remember it. Okay, so we're going to start off talking about those metric prefixes that mean more than 1 whole meter, liter, or gram. More than 1 whole meter, liter, or gram. But before we do that, I want to explain 2 things that I'm going to keep referring to as we talk today. One of them is the dollar bill. Since we all understand money, You guys all get money. We're going to talk about the $1 bill. That is going to also be one of my base. I'm also going to refer, and I really need a picture of the meter stick that you have on your desk. I'm going to be referring to that meter stick because I'm going to talk about 1 meter is also, of course, at my base. And I'm going to talk about how these metric prefixes, how they change the meaning of the base meter. Okay? We're going to start off here with kilo or kilo. It's like tomato or tomato. Kilo is abbreviated with a small k, and kilo means 1,000 times the whole. So 1,000 times the whole. So 1 kilometer is equal to 1,000 meters. My metric prefix, kilo, 1 kilometer is equal to 1,000 meter sticks. So if I told you I wanted you to go run 1 kilometer, you would take 1,000 of the meter sticks that you guys have on your desks and lie them end to end, and that would be 1 kilometer. Now, money. What kind of money am I talking? When I'm talking about a kilometer, I'm talking about a $1,000 bill, like $1,000 bill. Within that $1,000 bill, there are 1,000 $1 bills. Okay? Next up is for kangaroos, have stands for hecto. It's abbreviated with a small h. Hecto means 100 times the whole. So 1 hectometer is equal to 100 meters. Hecto is the prefix. Meter tells me I'm measuring length. 1 hectometer is equal to 100 meters. So, again, 100 of these meter sticks end to end equals 1 hectometer. How many meters does it take to go around the track? Who are my track stars? It's 400 meters around the track. So 1 track would be 4 hectometers is 1 time around the track. Okay, to give you an idea of size. What kind of money do you think I should think of when I say hectometer? $100 bill. Okay, so in my $100 bill, I have 100 $1 bills. Okay, last but not least, on the big side, when I'm talking about more than 1, I have deca. It's the only metric prefix that has two initials in its abbreviation, and it's DA. Deca, DA, is the abbreviation, means 10 times the whole. So 1 DAM. Oh, no, that's not the bad word. That's like the water, holding the water back dam. That's not the bad word. Just checking you, see if you're paying attention. 1 decameter is equal to 10 meters. Okay? So deca, D-A, is my metric prefix. Meter is telling me I'm measuring length. So 1 decameter would be 10 meter sticks laid end to end. Probably about the distance of our hallway here is probably 1 decameter. Okay? What kind of money should I think about? A $10 bill. Nice job. So we've got a $10 bill. In one $10 bill, I have 10 $1 bills. Does that make sense? Everybody understand how that money works? All right. So now we've talked about the things that mean more than 1 meter stick. Now we're going to take our items and we're going to chop them up. Now we're going to talk about the metric prefixes that are going to take my dollar and chop it into pieces. Okay? So now we are talking about the metric prefixes that are less than 1, less than 1, and again, I'm kind of chopping up my dollar and my meter stick. Okay? We'll start first with deci. The abbreviation is just a small d, not to be confused with deca, which is DA. That's 10 times the base. Deca is just a little d. And it means 1/10 of the whole. So if I have 1 whole meter and I'm going to chop it up into decimeters, how many pieces am I going to have? What do you think, Elise? No. 1 meter would not equal 1 decimeter. Nick? 10. Very good. I'm going to chop my dollar or my meter stick into 10 pieces. All right? Everybody look at your meter sticks on your tables. Everybody's got one. Please tell me you've got them laying on the metric side. And then tell me, what does it look like? What does a decimeter look like on that meter stick? How can you tell it's a decimeter? There are 10 of them on your meter stick. So how do you know what the decimeter is? Take a look. How do you know? How do you know? April? Right, and they're the big, bold numbers, right? The numbers are a little bigger. They're every 10 apart, and there's 10 of them. They're the big, bold numbers. I happen to be really lucky. My palm, from across my palm here, is about 1 decimeter wide. You guys can check yours. So what kind of money am I talking about if I take my dollar and I chop it into 10 pieces? What kind of money am I talking about? Dimes, of course. I'm talking about dimes. There are 10 dimes in $1. All right? Let's move on here. Let's see if I can get this done. Centa is a C. Centa means 1/100th of the whole. So in 1 meter, I have 100 centimeters. In 1 meter, I have 100 centimeters. So if I take my dollar and I chop it up into 100 pieces, I would be talking about pennies. Nice job. Pennies. In $1, I have 100 pennies. Nice job. On your meter sticks, every single number that you see, that's 1 centimeter. That's what I said. My pinky is 1 centimeter wide. You guys can look at your meter stick. Last but not least, I've got milli. It is abbreviated with a small m. It means 1/1000th of the whole. So 1 meter is equal to 1,000 millimeters. Milli is my metric prefix here. Meters tells me that I'm measuring length. So this is the only one where money doesn't work, because I'm talking actually about parts of a penny. Parts of a penny. So that doesn't, money kind of falls apart on me there. But if you look at your meter sticks, look at those little itty bitty baby lines on the meter stick. Those are your millimeters.
You're not Thursday afternoon. Attention Spanish students who missed science class today. Report saying, once you've missed 12 introduction metrics, post school point website in the